Welcome back. In today's class, we are going to be discussing everything that has to do with number bases. In mathematics, number bases stand as a tool that we are using to compute arithmetic operation. In a nutshell, number basis means scale of arithmetic operation. I know this word is too ambiguous. I will simplify it. A scale is something that measures how much something is. For example, if you take 10 plus 10, your answer is 20. Do you know the reason why the answer is 20? Because you are working on base 10. All of this will soon be clear to you when we start working out what number basis is doing. But I must let you know that we have more than base 10. We have base 2, we have base 8, we have base 16. Virtually, you can do your operation in any basis. All these bases come around based on scenario and the need for them. And we are going to look at some common bases that you are going to be dealing with. Without further ado, let's turn to our board to see what is going on. So, if you look at the number basis that we are talking about, it is dealing with something that has to do with how numbers are added together, how numbers are subtracted, how numbers are multiplied, how numbers are divided. For this reason, we need to exercise some patience. To see what number basis is all about. Number bases are the scales used to perform number operations. Operations like addition, subtraction, multiplication, division. The standard scale used in day-to-day operation is base 10. That is our standard scale, base 10. That's the reason why if you want to do any operation, we cannot talk about any operation without talking about base 10. If you are coming from base 2, you want to convert to base 15, you have to go through base 10 before you get to base 16. There are other scales, as I have told you, used in computing. The most important thing to know is that every base, every scale that we choose, which is our base, depends on the use case. Example, base 2 is used in computer CPU, because computer did not understand anything, any number than is 0 and 1. Everything you are saying on computer is bunch of zeros and 1. E.g., computer writes I love you as this. Do you see? This is computer for the word I love you, and this is what computer will save in its own memory. How do we do it? How did this come about? How did they achieve this procedure? How do we know that this is what computer is saying, that I love you? This is because in computing, when it comes to writing program to convert one thing to another, there is something that is involved, either compiler or interpreter. In this compiler or interpreter, there is a particular logic that enable every program to get what a particular value is in their binary form. Binary form is the form that consists of zeros and one. You can see here that 0, 1, this one here, let me take my marker, I'm sorry. So this one here stands for the word I, while this one stands for the space, because between I and that L there is space, while this one stands for the small letter L. If it is capital letter L, the binary will be different. While this one is small letter O, if it is capital letter O, the number will be different. While this one is small letter V, if it is capital letter V, it will be different. While this one is small letter E, if it is capital letter E, it will be different. While this one is the second space. So you can see that space and compare their number together. You can see that the space, their number is the same. While this one, it is letter Y, it is your, and that love you. While this one is letter O, and the word I love you. While this one is the letter U. So how is this thing possible that the word I love you is converted to this? You see, mathematicians were people that has to do with a lot of secret. If you are a scientist, you should be able to know a lot of encoding principle. There is particular encoding that we are using in computer today. We call it American Standard Code for Information Interchange. And that is the table, that is the instructions every programmer puts in their compiler, that wherever you see letter L, are you getting me now here, this particular letter, wherever you see letter L, we have assigned 73 to it. Then this is 73 in base 10, converted to what? To binary number. You can see that from letter to binary, from letter to decimal, from decimal to what? To binary. This is how they achieve conversion of number from one base to another base. This is very important because tomorrow, maybe later on, you will be the next person to invent the next number base that is very important to solve critical problem. But this particular ASCII code, which is American Standard Code for Information Interchange, does not cover all the letters in the word. For example, if I say Tinubu Negbuazu, if I say Tinubu Negbuazu, the letter Bu does not have equivalent decimal number in American Standard Code for Information Interchange. It is only if you want to use some letter combination which cannot interpret exactly the letter Bu. So maybe peradventure you are going to be the next inventor of CPU, that you will build a CPU that will understand specific or almost all language in the world. This is the reason why we are having binary. We are having binary because computer that we are using today does not understand anything than zeros and one. In the next future, you may be a person that will invent something that will understand something between 0 and 4. That is to say, you are working in base 3. If you are working in base 2, that is, you can have from 0 to 1. If you are working in base 3, you can have 0 to 2. If you are working in base 4, you can have 0 to 3. That is, all digits cannot up to that scale. If they are up to that scale, you have to remove the scale from the answer. The remaining is what you are going to write. Please, if you don't understand this, repeat the video to understand what I say. For example, if you say 12 plus 9, 12 plus 9 is 21 in base 10 because 2 plus 9 is 11. It is more than 10. That is the scale that you are using to work. So what are you going to do? You remove 10 from that 11, it remains 1. That's the reason why you are left with 1. But you know that if you are working with base 2, how many times are you going to remove that 2 from 12? until you reach a number that is not up to 2. You are going to do that like 6 times. But when you are working in base 10, you only do that 1 time. When you are working in base 5, you only do that 2 times. When you are working in base 4, you are going to do that 3 times. That is what basis is all about. I hope you understand what number base is all about. You understand that it is a scale that we are using to perform day-to-day operation, and it is the scale that determines the output of our operation. I will see you in the next class, where we are going to be working out some tools to let us see how we can possibly convert number from one base to another. It is very simple. All you need to understand is basic principle. What are the basic principles in this case here? You are having a number, you are having a base, or you are having an outcome. How will the base control the number to give you a specific outcome? Is what we are going to be looking at in the next class. Follow us, go to our YouTube page, subscribe to that, and turn on your notification so that whenever we drop our video, you'll be the first to get notification and watch and enjoy that video. In this series, we'll be explaining everything that you know about mathematics step by step, and where they are useful, we are going to be letting you know the reason why they are like that. Thank you for listening. ABP.